The heaviest German self-propelled gun withstands a direct hit from a 50-kilogram shell, yet the crew inside dies instantly from a monstrous internal shockwave. It is July 6, 1943. A heavy projectile screams across the Kursk salient. It slams into a Ferdinand, later renamed the Elephant. This vehicle carries 200 millimeters of frontal armor. That is nearly twice the thickness of a heavy Tiger tank. It weighs 65 tons, exactly 25 tons more than the Soviet Su-152. The distance is 800 meters. The Soviet crew fires a massive high-explosive round. The shell strikes the thick German steel. It does not penetrate. Instead, 6 kilograms of TNT detonate against the exterior. The shockwave rattles the massive steel plates. Inside the enclosed fighting compartment, the kinetic transfer triggers severe spalling. Shards of inner armor shear off at rifle bullet velocities. The blast wave and flying metal kill the crew immediately, leaving the vehicle's outer shell completely intact. Soviet commanders answer thick German engineering with the raw force of high-explosive blasts. The Su-152 fires rounds originally designed to shatter concrete bunkers. Pure kinetic energy overrides armor thickness. A direct hit on a lighter Panzer IV literally flips the 30-ton tank upside down. Against a heavy Ferdinand, the blast crushes structural welds and collapses individual plates. During the short summer night, German recovery teams tow these physically intact holes away from the front line, washing out the dead crews to send the vehicles back into combat the next morning. The heavy armor holds. Fuel and ammunition rarely ignite from the spalling. The weapon platform survives the encounter. Days later, the battle intensifies. 3 more Ferdinands fall alongside newly deployed Panthers and Tigers. The Soviet self-propelled gun eliminates the German armored Zu. Frontline troops give the Su-152 a new designation. They call it Zveroboy, the Beast Slayer. But leaving knocked-out tanks on the field becomes a strategic liability. The enemy salvages the thick hulls. Eliminating the crew is no longer enough to win the war of attrition. Soviet command issues a new, rigid order. Artillerymen must fire at immobilized German targets until complete physical destruction. The driver sits shoulder to shoulder with a large internal fuel tank. He remains trapped in his seat until the massive gun breech traverses away to clear his exit path. To deliver that 50-kilogram payload across the European battlefield, 5 men shared a steel box thick with the sharp scent of raw diesel fuel. A red-hot shrapnel fragment penetrating the armor meant instant immolation for the artillerymen. This layout was a forced wartime compromise built into a 45-ton assault platform. A 12-cylinder diesel engine produced 600 horsepower to push the wide tracks forward. They operated a weapon capable of launching projectiles up to 6,000 meters. However, accuracy degraded rapidly beyond the 800-meter mark. The gunner and loader sat crammed directly behind the driver. Total internal fuel capacity reached nearly 500 liters, turning the confined fighting compartment into a highly volatile environment. Soviet engineers never designed the underlying structure to carry such an extreme combination of heavy armor and artillery armament. The heavy tank chassis operated at the limit of its physical capabilities. 75 millimeters of steel protected the frontal plate. This cramped 45-ton casemate carried minimal shielding, stepping directly into the crosshairs of Europe's most accurate cannons. The Soviet howitzer fired in a high, unpredictable arc. Reloading took agonizing minutes. Meanwhile, German anti-tank guns delivered pinpoint strikes from over a kilometer away. The loader struggled with separate ammunition components inside the dim fighting compartment. First came the heavy 43-kilogram projectile. Then followed the massive propellant charge casing. Before the heavy breech block locked shut, enemy gunners fired 3 aimed shots in succession. The sides held just 60 millimeters of flat metal. Against older weapons, the 30-degree frontal slope offered survival. But the battlefield evolved. German forces deployed the powerful 88mm long-barrel cannon on their heavy tank destroyers. This weapon pierced more than 160 millimeters of armor at a distance of 1 kilometer. The Soviet frontal plate became vulnerable to direct hits. Long-range duels meant certain destruction. Soviet commanders changed their tactical approach. Breakthrough machines became ambush predators. During urban combat, they found a new purpose. Infantry no longer needed to clear heavily fortified buildings room by room. The massive assault guns simply collapsed entire multi-story structures onto their defenders. Close-quarters combat brought new threats. Crews initially relied on standard submachine guns fired through small ports. Later, factories added the 12.7mm heavy machine gun to the roof mounts. The deafening roar of the weapon echoed through ruined city streets. It slammed large-caliber bullets into upper floors and hidden sniper nests. Survival dictated strict combat spacing across the front. Assault guns no longer led the charge. The heavy vehicles trailed the first wave of advancing infantry by exactly 200 meters. Why would Soviet commanders deliberately deploy a machine with such obvious armor deficiencies to the active front lines? Traditional towed artillery was dying en masse during the winter offensive. The desperate need for this cumbersome heavy platform originated a year prior amid the freezing, snow-covered ruins of Stalingrad. Operation Uranus committed over 1 million Soviet soldiers to trap the German Sixth Army. However, this monumental encirclement quickly exposed a critical shortage of mobile heavy firepower. The Red Army shifted its strategic focus toward urban assault. Yet their offensive capabilities choked under the severe environmental conditions. Freezing winds swept constantly through the shattered city streets. Deep snowdrifts severely hindered the movement of standard support weapons. Artillery crews hauled their 76mm guns through the snow by hand to support the advancing rifle divisions. Yet these exposed formations often abandoned their artillery in the frozen mud during sudden German counterattacks. The Soviet offensive doctrine was suffocating without self-propelled artillery. Advancing infantry found themselves fighting without adequate heavy support, just as a new generation of German armor began to dominate the battlefield. Early engagements with Tigers, Panthers, and heavily armored Ferdinand tank destroyers proved that existing Soviet anti-tank guns were dangerously inadequate. The state required an immediate technological response. Previous attempts to mount a 152mm howitzer on a heavy tank chassis had already failed. That earlier engineering effort created the disastrous KV-2 project, which quickly proved entirely unsuited for modern mobile warfare. The towering turret made the vehicle catastrophically top-heavy and completely impractical for mass production during a total war economy. Acknowledging this fundamental design failure, the Soviet High Command officially rejected the outdated KV-2 concept. The military leadership issued an immediate ultimatum and demanded an entirely new turretless base for their heavy artillery. Factory cranes lower massive guns. Metal clashes against steel loudly. The heavy ML-20 howitzer drops. It meets the KV-1S chassis. It drops. No long trials exist here. Total war demands immediate solutions. State orders hit the factories. Orders arrive. The state demands a working machine. Designers scramble to meet aggressive quotas. The entire nation watches closely. They take 25 days total. Object 236 emerges incredibly fast. The KV-14 prototype is born. Compromise drives the rapid design. The assembly process is frantic. Testing takes just mere weeks. The military accepts the new design. 4 months later, lines roll. No delays. Mass production begins without hesitation. Factories operate around the clock. Armor steel quotas shift rapidly. The nation mobilizes its heavy industry. They merge existing heavy parts. Supply chains adapt to the new reality. Production speeds break all records. Inside, the crew fights tight space. Space shrinks. The loader struggles very hard. The environment is severely restrictive. He lifts a 50-kilogram shell. The heavy metal slips often. He pushes it forward blindly. He rams it home slowly. The massive breech clangs shut. This heavy process drains all energy. The crew operates in near darkness. 2 heavy rounds fire per minute. High explosive shells pack massive power. 6 kilograms of TNT weight. One shot obliterates thick concrete bunkers. Whole buildings collapse instantly. It fires. The 45-ton beast lurches violently. Smoke fills the cramped cabin. This machine solves a strategic crisis. Production numbers tell the incredible story. Factories spit out heavy armor daily. Time is up. The industrial response shocks the enemy. 700 heavy units emerge. They build them extremely quickly. Less than 10 months pass by. The scale is completely unprecedented. The total combat payload is strictly limited to exactly 20 heavy shells per vehicle. Infantrymen and flamethrower operators march shoulder to shoulder with the heavy steel hull. They guard the massive machine from window ambushes. When the front shifted to fortified European streets, the 25-day compromise project needed a fundamental base upgrade. The ISU-152 platform emerged. It utilized the heavy Iosif Stalin tank chassis. This base was designed specifically to carry significantly increased armor weight. It reflected a strict doctrine shift from defense to aggressive siege. Frontal protection thickened to between 90 and 100 millimeters. The assault gun could now approach enemy bunkers directly. It easily absorbed incoming fire. In urban combat, these machines formed tightly integrated assault groups. Submachine gunners cleared blind spots. Snipers neutralized sudden roof threats. Flamethrowers incinerated dug-in defenders. Infantry protected the vulnerable guns. The heavy artillery shattered the reinforced city blocks. The vehicle evolution continued further. Engineers actively tested extreme firepower for future field engagements. The experimental Object 246 mounted the long BL-8 gun. The test results were definitive. The weapon pierced 200 millimeters of thick steel from a distance of 2 kilometers. This heavy urban howitzer was just one part of a vast program. Soviet self-propelled artillery networks expanded quickly. Light assault machines always arrived first. The Su-76 supported aggressive, advancing infantry. Frontline combat crews quickly despised it. They nicknamed it the Bitch. Armor was thin. Constant mechanical breakdowns in the field guaranteed an immediate combat death. Specialized anti-tank platforms followed next. The Su-85 constantly hunted German armor. The Su-100 eventually joined them. But the heavily armored ISU-152 ultimately remained completely supreme. It was invulnerable. It erased targets. Soviet assembly lines never actually stopped. Factories built 4,000 heavy units by 1947. Then, doctrines shifted. Assault guns died. Breakthrough machines vanished. Modern main battle tanks like the T-54 combined firepower, mobility, and thick heavy armor to make direct-fire siege vehicles permanently obsolete across the entire post-war world.